Hi guys, I dare say many of you would be able to tell me about the angles in a four-sided shape from the knowledge that you know about squares and rectangles. You could look at this and you could say, okay, that's a right angle, that's a right angle, that's a right angle, and that's a right angle. A right angle is 90 degrees. I've got four lots of 90 degrees, so that would be 360 degrees. And that would be very much the same within a rectangle. But can we assume that's true for all four-sided shapes? Quad meaning four and lateral meaning sides. Well, let's think about some earlier knowledge about triangles that we have. If I was to take this quadrilateral and divide it in half like that, you can see I've got two triangles. And in a triangle, we've got 180 degrees. Remember, the angles in a triangle were supplementary. That was my maths word that I used on that video. So overall here, I've got two lots of 180 degrees. And that does come to 360 degrees. So what we can deduce from all of this is that angles in a quadrilateral add up to 360 degrees. And a question you might get on these sorts of things, you might get something like this. You might say, find the size of angle A. You might have those angles given. So what you would know is this one is 90, so you'd have 90 plus 115 plus 100 plus A is equal to 360 degrees. Now if I add all these up, I get 305 plus A is equal to 360. So taking 305 from both sides, I would get that A was 55 degrees. So that's a typical question where you're given three angles and you have to work out some more. Now you could get some of the more regular quadrilaterals. For example, we might get this shape, which is a parallelogram. Those ones are parallel and those ones are different, but they are parallel to each other. That's why I'm giving them two arrows. And I might get given this angle here as being 80 degrees and asked to find angle A. Now you might think, oh, I haven't got enough information there to tell me what these angles would be. But when you look at that, you could see, okay, co-interior angles from the parallel lines work that we did add up to 180. So you would have A plus 80 equals 180, and it doesn't take you to be Einstein to realise that A is 100 degrees. And we've also looked at the symmetry of some of these quadrilateral shapes. And if I look at two in particular, I don't know how to draw this, that's not bad. So there we have a kite. If I said this was 120 degrees you might also be able to tell me that there's a line of symmetry. So that would be a perfect reflection, and so would therefore be 120 degrees. So that could be a way of working this out. There's also, so that's a kite. There's also something called an isosceles trapezium. Now an isosceles trapezium is your perfect roof shape. And it's basically, it's a trapezium where these are the same sides. These sides here are the same length, much as in an isosceles triangle. In fact, if you imagined an isosceles trapezium with where this length was 0, you would have an isosceles triangle. So the thing about a trapezium is one set of parallel sides, and this is an isosceles trapezium. So that has a line of symmetry. Again going down the middle. So what that would mean is that these angles are the same. So those two obtuse angles are the same. And also these two acute angles would be the same as each other, just because one's a mirror image of the other. So what skill we're calling on there is symmetry. So just as a quick recap, all the angles in any quadrilateral add up to 360 degrees, and that's basically because any quadrilateral you could draw could be split into two triangles, and each triangle has 180 degrees in it. A typical question would be to be given some of the angles and then being asked to find another one, but we may also be asked to use some of our skills on some of the more regular four-sided shapes like the parallelogram, the kite and the isosceles trapezium. These two in particular, looking at lines of symmetry. We know a parallelogram doesn't have any lines of symmetry because there's no way you can fold it over onto itself perfectly. But we can think about those properties of parallel lines that we've already worked on. So the idea of co-interior angles adding up to 180 degrees. So pulling lots of skills together, but that figure of 360 is really important here. Okay, thank you.